Hello everybody. Now we are back with new topic called DMA. So we will be going through the working of DMA, which stands for Differential Mobility Analyzer. So basically DMA is used for measuring the particle size. Earlier we were having different techniques, like we were using optical techniques in order to measure the particle size, and now we are moving on to DMA or DMPS system, which is able to measure the particle size, like smaller particle size than optical techniques. In optical techniques the size of the particle was limited. We were able to measure like 50 to 100 micron only, nanomicron. Then with DMA it has been reduced up to 2 to 5 nanomicron. So that's why we are moving on to DMA. That's a typical diagram of DMA working. Just a sec. Where is the pointer? So this is a typical diagram of DMA working. So as I have discussed in previous slide, earlier we were using optical techniques. Now we are moving on to differential mobility analyzer uses. So basically DMA classifies the charged particle based on their size, and that is dependent on mobility also. Like greater the size, if the size of the particle is larger, okay, then the ability to carry the charge will be higher, and with smaller particle the ability to carry the charge will be little lesser when it is subjected to certain electrical field. So based on this mobility or charge available on the particular particles, DMA classifies different sizes particle based on charge capacity or charge carrying mobility. So after DMA it is like equipped with CPC, which I'll explain with decent diagram in upcoming slide. And basically DMA classifies the different particle based on their mobility, and CPC count the size of the particle. That is how whole DMPS system works. So with DMA plus CPC, it's uh, jointly known as DMPS. So you might be wondering like which particle size. So basically DMA measures the size of aerosol particle. What is aerosol? Aerosol are liquid or solid particles suspended in a gas. So aerosol are responsible for air pollution as well as health effects. Other than air pollution and health effects, aerosol are also important factor in climate effects with respect to radiation. So now we will move on to working of DMA. We will keep this video short so that like a larger content could be covered in small time or lesser time. So let's move on to working. So that's handmade diagram of DMA working. We will be going through animated or like digital diagram also. With that diagram you will be understand in a better manner. Right now you just stick to this diagram only. So just see here, there is opening or input for aerosol sample. So we will put the aerosol sample via this opening, and here we will pass the slith air. What is slith air? Slith air is nothing but a clean air without any kind of dust or pollution in it. Okay, so there is a aerosol sample, that is a slith air. This is high voltage road. Whenever this aerosol sample goes through this, like with mixing with slid air, then here it gets in contact with electrical field generated by this electrical rod. So it carries certain charge, and the particle with more size, like basically greater particle will be having more mobility or electrical charge, and smaller particle will be having lesser electrical charge. So based on that there is an opening for opening of certain certain geometry or certain dimensions. So for example, there this opening could be of like minute dimensions, like 2 nanomicron. So in that case, only particle having size of 2 nanomicron will be able to pass through this opening, and remaining particle will be exhaust out. So that's how the smaller size of the particle is being measured. After this opening here, it is connected with the CPC, wherein the size of the particle is being calculated with the help of MCU. So that's how typical DMA works. Let's move on to digital picture. So this is typical DMA diagram. Okay, then there is high voltage load, sleek air is there, then aerosol sample is there. It mixes with sleek air, then comes in contact with electrical field. It gets mobilized, it carries electrical fields. Based on the size of the particle, different mobility is present on different size particle. There is a opening of certain dimensions, wherein, like for example, if this opening is of 2 micron, then a particle having size of 2 nanomicron will be able to pass through this opening, and remaining will be exhaust out. So that's how it works. So that's whole DMPS or SMPS system. It carries a classifier DMA, it carries CPC, and jointly it is known as SMPS or DMPS system. So DMA classifies the different size particle, and CPC count the size of the particle. CPC carries MCU and all, which particular count or count the number of particle as well as determine the size of the particle. So that's how typical DMA as well as SMPS system works, which is basically used to measure the size of the particle of aerosol. And after this DMPS or SMPS system, we are using ESPS system also, which is used for measurement of exhaust gas particles, like exhaust of, we are having cars and all, and heavy duty vehicles, light duty vehicles. So whatever exhaust is coming out from exhaust pipe, the size of the particle is being measured with the help of ESMS system. So which is basically a copied version of DMPS or SMPS system only. The principle is same, little difference is there, like there is a charger in the starting place only, which gives the charge to the particle. So whole different working is there. You just need to understand, like for exhaust gas also we are having a different kind of system which is similar to SMPS or DMPS system. That's okay for today's video. Thank you, thanks a lot. Hope DMA working is clear to you.